Hi there, folks. Today we're looking at a couple problems that deal with quadratics. For those of you who have fallen a little bit behind, we're going to do a couple of these selected answers. So here we go. If we look at the first one, when we're graphing these things, the first thing we want to do is find the vertex. This one is in my standard form, so to find the vertex, I have to do the opposite of b over 2a. All right. When I do the opposite of b over 2a, it will give me the x value for my vertex. So my b value is right here. It's a -4, so the opposite of that is a +4. Over 2 times a, which is right here, is a 1. And now I just simplify this, 4 over 2, which is a 2. So that's my x value for my vertex. If I want the y value that goes with it, I have to plug that 2 into my equation. So y equals, that's going to be a 2 squared minus 4 times 2 plus 3. And I just simplify this. That's a 4 minus 8 plus 3, which is a -4 plus 3, which is a -1. So my vertex for this one is a 2, -1. The axis of symmetry is always x equals. And it's got to be x equals because that's the equation of a vertical line. And it's always going to be x equals the x value from the vertex. So x equals 2 for this one. The y-intercept, when it's in standard form, the y-intercept is always the c value. It's always the constant term. But another way we can look at that is the y-intercept is always when x equals 0. If I plug zeros in here for x, it's going to leave me with that last term, the 3. So again, that was a 0, 3 for my y-intercept. I plug a 0 in for x. I get a 3 out for y. Okay? And then the x-intercepts, these are the ones that we're really interested in when we're solving quadratics. The x-intercepts are when y equals 0. So if I were to plug a 0 in for y, it would give me x squared minus 4x plus 3 equals 0. All right? And then I would want to solve this one by factoring. So I would build a bridge. That gives me a +3. Two numbers that multiply to a +3 but add to a -4 are going to be a -3 and a -1. Okay, they multiply to a +3 but add to a -4. So now I can solve this one by factoring. So I factor it. It's going to be an x minus 3 times an x minus 1 equals 0. And now I can set each factor equal to 0, so I say x minus 3 equals 0, and I do x minus 1 equals 0, and I solve each. So here I add the 3 to each side, so I find out that x equals a 3. Here I add the 1 to each side, so I find out that x equals a 1. And those are my two x-intercepts, so I get a 3, 0 as one of them, and then a 1, 0 as my other. So now I'm just going to go down through and graph all of this stuff. So I've got 2, -1. 2, -1 is right here. Oh, sorry, 2, -1. I'm a little bit off. There we go. 2, -1 is right here. My axis of symmetry is x equals 2. That's the equation of a vertical line. And I draw it as a dotted line. The next thing, my y-intercept is 3, which is right here. And I can use that dotted line I drew as a mirror, so I can reflect that point over here. And now my x-intercepts, I've got a +3 and a +1. And I can already see this parabola starting to take shape. So now I draw the best curve that I can draw. And that's it. Okay, so we're just finding each of these things one thing at a time. And again, the big things there are the y-intercept, you plug a 0 in for x. X-intercept, you plug a 0 in for y. In number 2, this thing is already in my vertex form. Remember, vertex form is y equals a times x minus h squared plus k. And the thing about vertex form is hk is our vertex. So instead of having to find the vertex like I did in the previous problem, it's basically written right here. All right? Inside the parentheses, that x minus h means I have to take the opposite of whatever this guy is. So instead of a +3, it's going to be a -3. But then the k value, it's plus k. So that's like plus a -4. So my k value is a -4. Axis of symmetry is still x equals a value. And in this case, it's going to be x equals a -3, the x value for my vertex. The y-intercept is a little bit trickier for this one. The y-intercept is where x equals 0. So I have to plug a 0 in for x this time. And I've got to simplify this. So that's going to give me a 3 squared minus 4, which is a 9 minus 4. So it looks like y equals a 5. So my y-intercept, I plugged a 0 in for x, and I got a 5 out for y. And then the x-intercepts, I'm going to do essentially the same thing I did above. except this time it's set up a little bit differently. So I'm going to set this equal to 0. And instead of solving this one by factoring, that wouldn't make too much sense because it's not set up nicely for factoring. I can't build a bridge here because it's not in standard form. So I'm going to solve this using the square root, which is essentially the same way I solve when I'm completing the square. I'm going to add this 4 to each side. I'm going to get the squared part by itself. So I get the x plus 3 squared equals 4. And in fact, when I'm solving by completing the square, this is the situation I try to set up so that I can take the square root of each side. And when I do that, I'm left with an x plus 3 over here. Whenever I take the square root of each side, I have to remember to do plus or minus that value. So it's going to be a plus or minus 2. And now I can subtract the 3 from each side. So I find out that x equals a negative 3 plus or minus 2. But I wouldn't leave it like that. Since I have nice, neat numbers here, I can actually do the addition and subtraction here. This literally means two things. It means that I'm going to do negative 3 plus 2, which gives me a negative 1. It also means I'm going to do negative 3 minus 2, which gives me a negative 5. Okay? So my two x-intercepts are the negative 5, so it's negative 5 comma 0, and negative 1, so negative 1 comma 0. So now I'm going to plot all of this stuff. So negative 3, negative 4 is down here. A y-intercept of 5 is right here. Sorry, I skipped to my axis of symmetry. Again, is always a vertical line. And the reason I'm drawing that is so that I can reflect this point over here. A negative 5 and a negative 1. Negative 5 is right here. Negative 1 is right here. And I can see the parabola. It looks like this. Okay, and that's it. So again, y-intercept, I plug a 0 in for x. X-intercept, I plug a 0 in for y. And I solve using the square root this time. Okay?